Hi, this is the video recording for section 9.1. In this section, we're going to talk about real numbers, what they are, and how to evaluate radicals. We're not doing the third one there. We're only doing the first two objectives. Kind of trying to understand what a radical is and what a rational number is and an irrational number. So we'll kind of talk about numbers in general. You know, we have numbers that we start out with natural numbers and whole numbers, right? Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7. Natural numbers don't include 0, but we have these whole numbers. We have the set of whole numbers. Right? And if we include the negatives, those are the integers. But integers include all the whole numbers plus the negatives. Now, if we took those integers now and we made fractions out of them, so that there was an integer on the top and bottom of the fraction, then that is what we call the rational numbers. So it includes all the whole numbers and it includes all the integers in the rationals, because even a number like 3 could be written as 3 over 1. So they're all rational numbers. Okay? So the only thing that's not a rational number are numbers we call irrational numbers. And we'll talk more about some of them later, but they're numbers you can't write as a fraction. Okay, so all the numbers we can write as a fraction are rational numbers. So we're going to talk about square roots. So it's nice to have in your mind the perfect squares. Okay, so a perfect square means that it was some number, some whole number, squared. So here are our perfect squares. 1, 4, 9, 16, 25, 36. And you can see, you probably recognize these from when you learn times tables, right? Those are the ones that come from a number squared. So this kind of shows you all the way up to 20 squared. You probably know a lot of these. You should at least be able to recognize them, right? So, like you might say, oh, 169, I don't know what, you may not know right off the top of your head what number got squared to get 169, but if you just recognize, oh, 169, I think that might be a perfect square, then you could figure it out. Okay, so I'd kind of like you to be familiar with these perfect squares. Know that 64 is a perfect square and that 81 is a perfect square, right? Okay, so here's some more terminology. We have this symbol called a radical sign. So this radical sign right here, it is what we use when we're talking about a square root, right? So let's just think about this one that we have as an example here. Okay, so this is the radical, right? This number under here, that is called the radicand. We don't use that word very often, but occasionally we want to refer to the thing that's under the radical sign, and instead of saying the thing that's under the radical sign, we could say the radicand, right? And when we talk about this whole thing, we're talking about a radical expression. So if we say radical expression, it means that it's got this radical sign in it, right? So the radical expression is a way for us to talk about a square root. And what the square root means, so if you have some number squared that equals another number, and that's what we talked about with our perfect squares, right? So let's just use as an example 7 squared equals 49. Okay, so 7 squared equals 49. Then that means the square root of 49 equals 7. But there's two numbers that might possibly be squared to give us 49, right? If I did negative 7 squared, that would also equal 49. Positive 49, right? Because it's a negative times a negative. And so if we look at it this way, there's two possibilities for what A could be. It could be 7, or it could be negative 7 equaling 49. But if we write it with a radical, it makes us differentiate between them. Okay? So the square root of 49 is going to equal 7, because that radical is telling us we want the positive one. If we want the negative one, then we need to put a negative in front of it, like this, right? So the negative square root of 49 will equal negative 7. Okay, so 6 squared is 36. So that means that square root of 36 is equal to, what do you think? Write it down. It's 6. It's a positive 6. And that comes from right here, right? So if I asked you negative square root of 36, then what would the answer be? Well, it would be negative 6, right? So we can even do it with fractions. Since I know that 2/3 squared is 4/9, then the square root of 4/9 is 2/3. I think I have this. 8 squared is 64, so the square root of 64 is 8. And here's our 49 again. So just like we talked about before, it has two square roots, right? Two numbers that when you multiply them together, they give you 49. And so you have to differentiate between the two, positive and negative. It's like we talked about earlier. Okay, so this time there is a negative in front. So the square root of 25 over 121 will equal what? So see if you can do this. Pause the video if you need to and see if you can figure out what the answer is. So hopefully you got negative 5 over 11. So the negative, I should change this to some other color that's not on here. The negative stays, right? If there's a negative here, there's a negative in the answer. And then we take the square root of 25 is 5, and the square root of 121 is 11. And they go directly across there. All right, so the square root of 100 is 10. The negative square root of 100, what will that be? Negative 10. So the square root of 4.41. Well, it turns out that this is still a nice square, even though it has a decimal in it. If we had just the number 441, then that would be 21 squared. It has that decimal in it, so it's going to be 2.1. So even though we have a decimal, and usually we're talking about perfect squares being without any decimals, we can still consider them if when you take the decimal they give you, if it's a simple decimal and it's not going to be repeating or anything else. Okay, so now this one wasn't even on our list because it went above 20, but you might notice, you might remember 144, and you might remember that that's 12 squared, right? And this is backwards 144. This is 441, backwards of 144. And so it turns out that it's backwards of 12. Now, not all of them turn out that way because of, the borrowing and carrying and stuff like that, but this one does. Turns out to be 21. If I just had the square root of 441, it would be 21. And since there's two decimals, so if that decimal had not been in the second place over here, I wouldn't have been able to do it. It had to be in a place where I could have the same decimal each time and still get the answer. Okay, so here's where we talk about the irrational numbers, are the imaginary numbers, the ones that aren't even real numbers. Because if we take, going back to when we were looking before, and we had all those rational numbers. So rational numbers and irrational numbers, ones that can't be written as a fraction, they're still real numbers. They could still be found on a number line, right? You could still figure out whether something is greater than it or less than it. It still has an amount, right? And that makes them what we call real numbers. And then we have numbers that are not real numbers, right? So they sometimes call them the imaginary numbers or the non-real complex numbers. It's sort of unfortunately named, but you'll talk about that later, because imaginary makes you think that they don't exist, whereas they do. They're just not on our number line. And so they come from the ones that we can't find an answer to, right? So the square root of -4 doesn't exist in our real numbers. Okay, so there is no number that I can multiply by itself and get -4. You can't, because if it's a positive number, then when you multiply by itself, it'll be a positive number. But if it's a negative number, if I multiply by itself, it'll be a negative number. So we need something that's not either one, right? And that's where we get our imaginary numbers, and you'll talk about those in a later class. But if there's a negative under the radical, then it's not a real number. Okay, so -25, even though the 25, if it's just squared 25, it'd be 5, but it's not -5, because if I did -5 times -5, that would be positive 25 too, right? So these don't have an answer in our real numbers. So we would just say it's not a real number. So squares are not the only ones we can talk about with these radicals. If I did cubes, and here are the perfect cubes, right? So maybe you recognize some of them. Of course, 1 is also a perfect cube, because 1 cubed is 1. And 2 cubed is 8. And 3 cubed is 27. And 64 is 4 cubed. And you notice that, remember, 64 was a square root as well. I mean, a perfect square. And it's a perfect cube as well, which is interesting. But anyway, these are all the numbers up to 10. And we probably would never even go, we probably would not go higher if you were just finding it, or you can find a way to do these on your calculator. But those are our perfect cubes. And so that means we could talk about a cubed root, right? So a cubed root, when we do the cubed root, we use the radical with a little 3. And so it's a small 3 that goes right in that little corner there of the radical. Notice if we don't have a number there, we assume it's a 2. Like when we did a square root. Square root of 49, we're thinking, we're acting like there's a 2 there. But if it's not a number there, then we assume it's a 2. If there is a number there, that's the index. Okay, so still called a radical. This symbol is still called a radical. This under here is still the radicand. And this is called the index. So in all those square roots, that index was 2. And if there's no index written, we assume it's a 2. Okay? So let's think about one of those numbers we just talked about. We know that 2 cubed is equal to 8, right? So that means the cubed root of 8 is equal to 2. Now, here's an interesting thing about cubed roots. Oh, there's the one, the very one I just did. So if we know that 4 cubed is 64, then the cube root of 64 is equal to 4, right? But now this one is the interesting one because it's negative. But you see that negative 6 cubed is negative 216. So it's not like when we did square roots, and if you took a negative and you squared it, that still gives you a positive. So that means that positive number had 2 square roots. That's not true for cubed roots. It actually is different. So I can do the cubed root of a negative number, and it will be the answer. Oh, I forgot. It's going to be written here. The answer will be a negative number. And we can do it with fractions, just like we did with square roots. If I know that 1/3 cubed is 1/27, then the cubed root of 1/27 would just be 1/3. So irrational numbers are still real numbers, but they're numbers that you can't write as a fraction. And in fact, what happens is if you try to write them as a decimal, they keep going and going, and they never repeat, and they never end, and they just keep having more and more and more, right? So some decimals, like if we talked about 0.25, well, that's the same as 1/4. So 0.25 is a rational number because it could be written as 1/4. But if you have a decimal that doesn't end and keeps going, and for you to write it down, you have to round it off at some point. Even if you put 10 or 20 digits, you still, at some point, you have to round it off because it's not ever going to just be done. Those are called irrational numbers. They cannot be written as a fraction. So most of the square roots, in fact, any square root that's not a perfect square, is going to be an irrational number. Okay, so we know about what it is. We know that the square root of 2 is going to be bigger than the square root of 1. So it'll be bigger than 1. But it's smaller than the square root of 4. Right? So the square root of 1 and the square root of 4, those are our perfect squares of 1 and 2, right? So the square root of 2 is going to be in between there. So I know that the answer is going to be somewhere between 1 and 2. So when you plug it into a calculator, and we'll talk about that in a minute, you get this number. But now your calculator will show it ending at the end of your calculator screen. So however far it goes, however far your calculator goes, that's how far it's going to take it and round it off. But know that it's rounding it off at the end of that so it can write it down, but it really keeps on going. And if you want to look in your book at the beginning, there's actually a proof that proves that it's irrational, that you can't just, if you found the right fraction or big enough numbers on the top and bottom, you would get it. You really can't get it. All right, so the cubed root of 4 is also irrational because it's not a perfect cube, right? And I know that the cubed root of 1 is 1, and the cubed root of 8 is 2, so I know that the cubed root of 4 is somewhere between 1 and 2. All right, so it is still continuous like that, and it's still, we can still approximate it, but you'll have to take a calculator to get the most closest approximation. But it is an approximation because you notice that we can't actually write down a decimal that equals the cubed root of 4. But it's about 1.5874011. And if you kept going, you'd get more and more numbers. There'd never be a time when you actually were done, right? It would keep going. And if you got a bigger calculator or you got a bigger computer, you would get more spots, more numbers. It wouldn't actually ever be done. So some other irrational numbers that you know, one is pi. So pi, which I know some of you might think it's 3.14, but it's not. That is an approximation of pi, right? It's 3.14159, and so on, on and on. This takes it out to quite a few places, right? Here's another irrational number. It's the number e, and it's named after a mathematician named Euler, whose name starts with E, and it's Euler. And as you learn in your next class about exponentials and logs, then this becomes very important. But that's another irrational number. So there are quite a few irrational numbers. Okay, so in this case, the interesting thing about square roots is they're kind of the opposite thing that we're doing with squaring it, right? So squaring it will undo the square root. So in this case, they want you to find the square. In other words, we're going to find this. We're going to take that number and square it. So, well, remember that the square root of 15 is the number that you multiply by itself to get 15. And so here I am multiplying it by itself. And so it will be 15. So when you square it, it kind of undoes that radical sign, right? So the square root of 7, if we want to square it, it's going to be 7. What if I had the negative square root of 23? Now I'm going to square it. So I'm going to square this negative number. So if I take a negative number and multiply it by itself, which is another negative number, I get a positive answer, right? So I get that 23. So here's just kind of a general summary of what we've talked about. If a is a positive real number, then the square root of a is a real number. If a is positive. But if the square root of negative a is not real, okay? It's not that it's irrational, it's not even real. So an irrational number is still a real number. For it to be real, you have to be able to put it on a number line. I can place an irrational number on a number line. So if a was 15, the square root of 15 is still going to be something between 3 and 4, right? Really close to 4, but not quite. But the square root of negative 15, I can't even find it. It's not on my number line at all, right? All right, so hopefully you have your calculators. Pull out your calculators and try to find the answers to these here. On your calculator, you probably have a square root symbol somewhere, and if you're lucky, when you push the button for that square root symbol, it might pop up like a square root symbol and open up a parenthesis. Then you can type in 17 and then close the parenthesis and hit enter, and that will give you the square root of 17. Okay, so the square root of 17 should come out to be 4.123105626. Anyway, we'll leave it at there, right? So do that and make sure you know how to find these square roots on your calculator. Try the square root of 33 as well. And that should turn out to be 5.74456, and so on. Okay, now it's possible that your calculator works a little bit backwards, and possible that you have to plug in 17 and then hit the square root sign after, and it takes the square root of whatever you just had in there. It's sometimes a little less intuitive of how to use that, but it still works and it will still give you that answer. Okay, so try out your calculator, the calculator that you use, that you want to use for your test, so that you can get used to it, and see if you can get some of those. Figure out how to enter these in so that you can find the approximation to any square root. Most of your calculators will not do cubed roots, and I won't ask you to do any of those. If they are in the homework, then you may have to use a different calculator to figure it out. I can't remember if they are. I didn't give you any practice problems, so you're just going to have to do the homework to practice this, and hopefully it'll all go well, and we can talk about this in class on Tuesday, and if you have any questions about any of this. I'll see you later.